Okay, hello and welcome back everybody to Java Vaults. What we're going to be doing in this episode, it's going to be quite a long session, so this may split into more than one episode in the end, but what I'll try and do is I'll try and put them out as quickly as possible, and I might make them a little bit longer just to make sure I can fit as much of this in as I can. Basically by the end of this session we're going to be having a map drawn on the screen, and I'll show you how it's all going to happen and everything as we do it. But the first thing we have to do is make a game loop. What we're going to do for that is in our run function just here, we're going to start making a few variables just to keep track of time within the game. So we're going to make one called now, and we're going to get the nano time with it, and then we're going to make another one called last time, and for now that can equal now. Next what we're going to do is a time tick. This what we're going to do is we're going to do a billion. It's 1 with 9 zeros after it, and we're going to divide it by 60. This just tells us how many ticks we're allowed before it will start up a new tick in the game loop. And then what we're also going to do is make a second counter, which we now equal now as well. And what else do we need to make? No, I think that's it. So now what we're going to do is go into while, and we're going to do while running. Running is a boolean we set up earlier, which means it has either a true or a false value. We set this up earlier when we come into our start function, and we set it to equal true. So this loop will start. Now what we're going to do, the first thing we're going to do is do now equals system.nanotime, and I knew there were some variables I was missing. What we're going to do is in here is set two new longs, one that time since tick, which now can equal 0. Sorry, not 2, one new variable, time since tick. Okay, so now we're going to do now, and what we're going to do is we're going to do time since tick, it's going to plus equal now minus last time, and then we're next going to test if time since tick is greater than or equal to time per tick. That means that it's been a certain amount of time that now we should have to tick our game loop again. So what we're going to do in here is we're going to run a function called tick, and we're going to do ticks plus plus. Now I haven't made a variable called ticks, so we'll just create that little variable. And we'll take that and put it out here. So we'll also make one for frames as well. Okay, and then what we're also going to do is time since tick and minus equals time per tick. Okay, and what we'll do as well, we'll just make this function quick just so it's under here, and again that will be something we'll be doing in a later episode, and to initialize that variable. Okay, what we're next going to do is we're going to do frames plus plus render. Now if you don't know, the plus plus after the frames just means to increase it by 1, and this just saves me having to write plus equals 1 really. Okay, so we're going to do it like that. Just what we're going to do before that as well is do if. Now we're going to use our second counter. We're going to test to see if that's greater than a billion. What this will do is tell us that a second has passed. And now we're going to do system.out print hello. This is the function that allows us to print into the console, which will be shown at the bottom of the page when we're at the bottom of the screen when I run the function. In here, what we're going to print is we're going to print ticks. We're then going to print TPS, just so I know that's the ticks per second. And then we're also going to print frames and FPS. Again, just so I know that's the frames per second. Next thing I'm going to do is ticks equals frames equals 0, so it just sets ticks and frames back to 0, which sets our tick and frame counters back to 0 obviously, and then we're going to and then we're going to set a second counter, and we're going to do minus equals a billion again. Let's just reset back to 0. The last thing you have to do right at the bottom here is do that last time equals now. So this way we can just know, this will tell us how much time has passed between the now function up here and this, because when we come back around to the next now, the last time's been stored. When I run this now, what should happen? If you see at the bottom, it goes wrong. Okay, so we need to try and find out why it's going wrong. Let's have a look. So time since tick to the plus equal now minus last time. Should be fine. Time per tick. Okay. So we're a bit of debugging comes. So now what I need to know is what time since tick equals. I know. That's why. But it shouldn't. What I've got here, basically what we should have this as, second count should equal 0, and then should increase the same as time since tick should. So we'll just try and rerun that, and what we should now have is, yeah, there we go. So now you see we're getting 60 ticks per second. This allows us to just keep a constant time in our track, and wow, that's 65 million frames per second, 62 million frames a second maybe. Okay, so alright, it's not too bad. Obviously we're not printing anything to the screen, we're not really doing anything at the minute, so that's not surprising that the number's so high. Okay, the next thing we're going to do is we're going to have to make it so that we can print onto the screen. So up here we're going to make a private buffered image. We do need to name it as well. Just name it image, image. And we're going to make it width, height, and in this bit what we're going to do is, this is basically how it's going to store the information, and we're going to store it as a type in ARGB. Okay, and that just means that each part in that is going to be stored as a number, hex code, and you'll see them more later as we come into our colours and stuff. So next we'll make a private integer array called pixels, and in this we're going to make data buffer in using image, and we're going to get raster. Get raster, and then out here we're going to no use the right codes. We're going to do image dot get data, sorry, get raster. That's right. Get raster. And from here we're going to get data. And then we're going to get data. What that will do is it will link our integer array of pixels into our image, so we can directly write into the pixels array and it will affect the image. So what we're going to do down here is we're just going to start writing it so that it'll print the image to the screen every time. We are going to make a new buffer strategy, and we're going to look at from this dot get buffer strategy. Next, what we're going to do is we're going to test to see if it actually equals anything. So we're going to test to see if it equals null. If it equals null, this means that there's no buffer strategy made for our engine class. So what we're going to do now is we're going to do this dot create strategy. We're only going to use 2 buffer strategy, number 2 there, and then we're going to return. This then calls it to the next loop. It will actually come into our render function, and we can start drawing properly. Down here we're going to do graphics dot, do graphics G equals this dot get graphics. Sorry, it's not this. It's going to be bs dot get draw graphics. We're then going to do g dot draw image. The things we're going to use image. We're going to start at 0. We're going to get the width, get height, and set that to null, and all the rest can be deleted. What this does is just scale the image up to the size of the window.